Alright, Bogle High students. Hey, I wanted to throw one on here. Some of you guys mentioned you're having trouble solving systems with these matrices. So this is 5B from the workbook today. They give this to you in as three separate equations, and I've set it up here. You had to solve them for the constant, right? You had x, y, and z. You brought them all to the same side of the equation. Just wanted to note out that there was no x in the third equation. So you had 2.2y, 2.2z set for equal to a constant of 2.2. We're going to start off with that, I think. In fact, I'm going to go ahead and I'm going to do two changes right here. We're going to say, hey, you know what? Let us take row 1. We're going to add that to row 2. And that will be our new row 2. And what that's going to do is it's going to make this guy over here a 0, which is always nice. And I'm going to go ahead and all those are 2.2. So let's just get rid of that. We're going to take row 3. I'm going to write a division, but I'm going to say we're multiplying by 1 over 2.2, right? And that will be our new row 3. So the only row I didn't change with that is row 1. And I'm going to see if I can rewrite that really quick. I'm going to apologize to you guys in advance. Again, I'm not the best at writing with this new contraption, and it'll be a little bit messy. Row 1 has not changed. It's still -1, 3, -1, and 4. Now, adding these two together does what I want here. It makes a 0 in this first this row 2 column 1 spot. So -1 plus 1 is a 0. 3 plus 1 is a 4, right? And we got what? -1 plus -2 is a -3, and a 4 plus 0 is a 4 here as well. And this last, we're just dividing by 2.2, so it makes all of those 2.2s equal to 1. Which is kind of nice. I like these ones here. This one will allow me to do two things really quick. It's going to allow me to get rid of this 3. And it's going to allow me to bring this 4 down to what I want at 1. I could even switch spots if I wanted, but I'm going to go ahead and do two steps here. I'm going to leave row 3 untouched. I'm going to say the opposite, or 3 times the opposite, -3 of row 3 plus row 1 will replace row 1. And let's go ahead and do the same thing here. We're going to go -3, 3 times row 3, opposite of row 3, 3 times row 3. Added to row 2 is going to go ahead and replace row 2. So in this instance, what you notice is I did absolutely nothing with row 3. So I'm just going to write that back in here. We got 0, 1, 1, and 1. Anyway, 3 times 0, -3 times 0 is 0, so that -1 stays the same, which is how I want it. -3 times 1 is -3, which added to 3 gives me a 0. And -3 times 1 is -3, which added to -1 gives me a -4. -3 times 1 is -3, added to that 4 gives me a 1. Right? Same thing here. I keep my 0 here. -3 times 1 is -3 plus 4 is 1, which is what I want right there. -3 times 1 plus -3 is -6. And -3 times 1 is -3 plus 4 is 1. I'll go ahead and close out this row 3 right here. I notice that there's a 1 here and I want a 0 there, so I'm just going to say, you know what, the opposite of row 2, we might have to come to the top, plus row 3 is going to replace row 3. So again, in this case, I've only made one change, right? I haven't changed to row 1, which is still -1, 0, -4, right? And I haven't changed row 2, so I'm going to say 0, 1, -6, and 1. Here we go. Opposite of row 2, well, opposite of 0 is 0, so no change here. Right? It's not really an opposite of 0. It's kind of neutral. The opposite of 1 is -1 plus 1 is 0. Right? Opposite of -6 is 6 plus 1 is 7. Okay, we got that right like that. All right. And we got the opposite of 1 right here is -1 plus 1 is a nice 0. I'm going to bring this up to the top. But what's really nice, I've only got one number here, so I kind of like that. I'm just going to say, hey, you know what? Row 3 times 1/7 is going to change to row 3. And coming up top here, once again, all I've done is I've changed row 3, so -1, 0, 4, 1. Alright. Row 2 is unchanged. 0, 1, -6, and 1. And this one I just divided 0, 0 by 7. And 0 divided by 7 is obviously 0. And then we're just bringing that 7 down to a 1. Now I want to make zeros in here, which is really easy whenever you have a 1. So I'm going to say the opposite of 4 times row 3 plus row 1 is my new row 1. Let's go ahead and change this to, we'll say 6 times row 3 plus row 2 is my new row 2. And this should finish us up here.
What you doing?
Hey buddy, I'm doing a quick video for my Bogle kids.
What is it called?
Where we're solving systems with matrices. So here I go. I got 0. I haven't changed the last column. 1, 0, and I'll do this as quick as I can. So 6 times row 3 is 0 and plus row 2. We'll do this bottom one first. 6 times 0 is 0, so that stays the same. 6 times 0 is 0, so that stays the same. 6 times 1 is 6, plus -6 cancels that out. 6 times 0 is 0, again stays the same. Same thing all the way across here. The only column I have any of row 3 in is column 3, so everything's going to remain unchanged except for column 3. -4 times 1 is -4, plus that 4 is a 0. And we have our matrix that we're looking for over here, which gives me an x is equal to 1. Oh, no it's not. Look what I need to do here. And I'm just going to do this really quick because I might be running out of time. I didn't notice there was a -1 here. So I'm going to have to multiply all of that by a -1. I'm just going to do it real quick here. And now that gives me x is equal to -1, y is equal to 1, and it looks as if z is equal to 0. Again, just an example problem using these new augmented matrices, and I hope you guys get all your homework done. I'll see you tomorrow.